Hello, we are classifying numbers today, and some of this you might remember from last year, but I want to review it very quickly. So we're going to start here. What you see in front of you, the big circle, this is called a Venn diagram. So the Venn diagram is where it's a visual aid to show how all the numbers can be related and classified. And for our purposes, you'll notice that you have three circles. It's almost like the bullseye on a dartboard. So the center, or the very bullseye, is going to be whole numbers. So the whole numbers are starting at 0. We would just count up. This is truly the first numbers that you learned when you were really small. Is okay, we start at 0 and then we count up 1, 2, 3, 4, all the way up. 55, 123, 492. Those are all whole numbers, and you'll notice that there's no negative numbers, and there's no negative numbers, there's no decimals, there's no fractions. So these are the whole numbers. Then, going out from the very center bullseye, you have the integers. So you see over here, the integers also include the whole numbers, okay? The integers include 0, 1, 2, 3, etc., etc. But the integers, we also add negative numbers. But again, those negative numbers cannot be, negative 2.1 or a negative fraction. It still has to be the whole numbers positive and then the whole numbers negative. Those are the integers. The rational numbers, for your purposes this year, every number you're going to see is going to be a rational number. The easiest way to explain it is if we can write a number as a fraction, then it's going to be a rational number. So look at our examples. 3 over 4, or 3/4, that's a fraction, so that's rational. A rational number can also be a decimal, 1.2. It can also be a negative number, -3. So for your purposes, everything's going to be a rational number that we're dealing with right now. So let's look at a couple of example numbers. We have the number 17. Let's start in the middle of our donut here. 17, would that be a whole number? Remember, we start at 0 and we count up with no fractions and no decimals. So there's no fraction, no decimal, that's a positive number. So 17, and my marker's already running out on me. So 17 is definitely going to be a whole number. So we have 17 as a whole number, and I'll try to check that off. I'm sorry you can't see it very well. Now, if it's a whole number, we already know it's an integer, and all these numbers are rational numbers. So 17 is a whole number, an integer, and a rational number. Let's look at 3 over 2 now. 3 over 2, does that look like that would fit in this group? Remember, it has to be a 0 and then the counting number. 0, 1, 2, 3, 4, etc. 3 over 2, that's not a whole number. Is it an integer? Remember, if it's an integer, again, an integer cannot be a fraction and it can't be a decimal. That is a fraction, so it can't be an integer. So 3 over 2 would just be a rational number. That's all we can do with that. Let's look at 1.4. Same thing, we start in the center, and we know that a whole number cannot be a decimal or a fraction, so we know that's not a whole number. That can't be an integer because, again, integers don't have decimals or fractions. So 1.4, I'll try to write it over here, and I'm sorry that's hard to see. 1.4 is also a rational number. Now let's look at this one, -8, our last one. Our whole numbers have to be positive. There are no negative numbers in this group. So we know that -8 cannot be a whole number. Can -8 be an integer? Yes, it can. And the reason is that there's no fraction and there's no decimal. Integers are the 0, 1, 2, 3, 4, 5, so on, just like the whole numbers, but also the negative whole numbers. So -8 would be an integer. Now, again, if it's an integer, it's also a rational number. I didn't write -8 up here in the rational number bar because we know everything that's inside this bar or inside this circle or this circle, they're all going to be rational numbers.